conservation of mass is a really important concept to get your head around when it comes to chemistry. But not only that, our understanding of chemical reactions sometimes can be a little bit confusing, because remember the definition of chemical reactions. It is where two substances or two or more substances combine to give you something new that you have not had there before. And a lot of people think, okay, well, something's lost and something's gained. So for example, if we have CH4 here, which is methane gas, and we combust that with oxygen gas, then in complete combustion, we're going to get CO2 and water. Okay? And you've done balancing equations before, so we'll just balance this up here. Let's have a look. We've got one carbon, 4 hydrogens, 2 there. So let's put a 2. So it's 4 hydrogens now. We now have 2, 3, 4 oxygens. So we just put a 2 there. All right. So there's our equation for combusting methane gas. Now, this is the reactants and that's the products. But what you've got to remember is that even though we've formed new chemicals on the right-hand side there, the mass of what we started with in grams, whatever that might be, has to equal the mass that we finish with. Because there is a rule in chemistry that mass is conserved. In other words, we can't create anything brand new and we can't destroy it, right? Matter is neither created nor destroyed. And so if we start off with 10 grams over here, we have to have 10 grams over there. Even though the atoms have been rearranged to form new and different, in this case, compounds, but the mass should be the same. So we're going to explore this in this little chemistry lab here, and you'll do this probably in the lab as well. So let's have a look here. What have we got? Well, we've got some water, we've got a mortar and pestle, we've got a balloon, we've got some Aspro Clear tablets. Okay, so let's take the mass of all of this before we start. So we'll press the scale on. Okay, wait for it to go to 0. If it has a number there, just press the tare button. That'll take it back to 0. So I'm going to record the mass of everything we begin with. So that includes the test tube, which we will fill with water. So let's be precise and let's measure out a volume of water. So let's put it down and we will measure out 40 mils of water. Okay, so we've got 40 mils of water. Let's put that in there. So we've got 40 mils of water. So let's just write that down so we know. All right, so we've got 40 mils of water. Okay, and we've got our 3 tablets. And what we're going to do here is we're going to grind the tablets up just because it's a faster reaction rate. So we'll put them in our mortar pestle and we'll just grind them up. Okay, so we've ground it up now. I'm just going to put it on this piece of paper to get it into our test tube. So I'll put that in there like that. And we're going to put this into our balloon, I should say. So we just carefully place this in the balloon. Okay, and then now of course we're going to put the mass, I'm just going to put that there for the moment. And so we've got everything there in our system. So the mass of the system to begin with should be the mass of the end. And what does it say? It says 278. Okay, so the total mass is 278 grams. Okay, all right, so we're going to do this reaction, see what we get, and then see if the mass changes. All right, so I'll just tidy up the bench here and we'll do the reaction. This is where, it doesn't really matter. Okay, so let's do this reaction now. So let's get our, this is where you're probably going to need 2 people. It's a bit fiddly when you've got one person here, but you need to, let's just put it in here maybe, and we'll put the balloon over the top. Okay, so there it is. So we've got our tablet in here. We've got the water in there, so we will invert the balloon. It will go into the water, create gas. Hopefully we'll catch all of it and not lose any through this connection here. So we started off with 278. Let's put it up and see how we go. Give it a bit of a shake to make sure it's all reacted. Okay, so we've still got a little bit down the bottom, but it's reacting away to make the gas. Okay, pretty much done. So let's have a look here what it is. 277. So it's gone down by 1 gram. Which, yeah, the laws of physics and chemistry still apply here. So we've got to find out why we had 1 mass loss. Sometimes that can happen because the connection between the test tube and the balloon is not that tight. So you can probably get some sticky tape and put some sticky tape around that. If you do that, you have to make sure that you put the sticky tape on before you invert the balloon, and then make sure you include the mass of the sticky tape. So it might be maybe the balance, there's an inaccuracy in the balance, you've moved it and maybe the placement of that has affected it. Shouldn't, but let's just try it. Okay, so mine here, my mass, my electronic scales is only to, I guess, the nearest gram. And when I moved it there, it went from 277 to 278 back to 277. So it's probably telling me that if I had a more accurate scale, I might have 277.9 or something like that. So a very small mass change. So there you go. So we had the mass there, what we started with, pretty much equal to the mass afterwards, and that is the conservation of mass. All right, so hope you took some notes about that concept there. The mathematics pretty much works out with our degree of accuracy, and I hope you have fun doing this in the lab.